very much for this introduction. It's actually a pleasure to be here and talk a little bit about this topic here. And well, if we think about the climate change in the Alps, I just would call it a hot topic. And I guess all of you know a little bit what one of the most well-known effects is of climate change, and this is, of course, that our glaciers are melting. So I would first start with a little bit of an overall introduction and then go a little bit more into detail. So I also have to apologize. A lot of the headlines that I'm going to present to you are in German, because it's, of course, about German Alps, European Alps. And this is now a headline from a report that was released a couple of years ago. And the headline is Future Without Ice. And it was the title of the German glacier report. And I'm going to present a couple of more images from this quite interesting report. There was also a quite interesting article in the Washington Post in 2023. And I really like, well, liking is maybe not the right word, but I found this topic quite interesting here. So it was Europe's snowless ski resorts preview winter in a warming world. So the skiing conditions or snow conditions in last year, they were really bad. And they were so bad that even the Washington Post reported about the European conditions. Then this is an article from this year. It's from the skiing season in this year. It was released in March. It's about a skiing resort that is close to Munich. And it's one of the main skiing resorts where the people from Munich go. And they had to close the skiing season already in March, which is very, very soon. Then if we look out of the door, or if we looked last year out of the door, so this is Garmisch-Partenkirchen in January 23. And these are skiing conditions that we see basically every year from now. So you see these almost white slopes, and left and right of it, it's basically green. And this, of course, has some dramatic consequences. So in last year, they did not have enough snow for the skiing World Cup. So the famous skiing World Cup is usually organized here, and they could not do it last year. And also this year, they had to cancel the women's race here in Garmisch. And this, of course, has some dramatic consequences on tourism, so on the hotels and restaurants and so on. So it's a big topic, it's a hot topic, and it affects many people living in the Alps. And I would like to continue now with something that usually is presented at the end of a presentation, somehow the conclusions. But I just would like to give you a short overview about the current state of the art, what we know or what we assume to know about climate change in the Alps. Maybe most important, temperature is rising in the Alps. This is now well documented. It has been shown in many publications. And this temperature is rising at a rate twice as large as the Northern Hemispheric average, which is quite alarming. We also have a substantial increase in the number of climatic extreme events. Also, this can be observed now quite well. We have a substantial decrease of snow coverage between 1,500 and 2,000 meters. So that's in square meter, it's just the reference. And this obviously leads to a dramatic impact on the skiing resorts. And the altitude with adequate snow conditions for skiing increases from 1,200 to 1,800 meters. And quite interestingly, in Switzerland, currently only 44% of the skiing resorts would meet these requirements. So these are also quite alarming impacts. And of course, our glaciers are melting with a rate of approximately 1.3 gigaton per year, or almost 2 to 3%, which is also quite dramatic. In the next couple of minutes, I would like to present to you some studies, not from us here, but some studies about climate change in the Alps that I found very interesting, very representative. And I would like to start with a study from 2023. It was released in Nature Climate Change, and it was about the decreasing snow cover. And what the researchers did here is they used a plant. I'm no plant expert at all, so please correct me if I say something wrong. They used prostrate shrubs, which is a quite long living plant that is populated all over the Alps, basically. And they took these plants, 572 of them, and they checked the annual rings. And based on these annual rings, you can detect if it was a snow-rich or a snow-poor winter, actually. And they did this over the Val Venezia, which is a valley in Italy. And they came up with this figure here. And just have to see where the mouse is. So this red line here, this is basically the data that they have recovered from these annual rings. And they could see that in this period, the number of days with snow coverage reduced by 36. And they also did a kind of backwards continuation or a recreation of this data. And they could basically conclude that such a decrease could not be observed or measured in the last 600 years. So this is really alarming. This decrease in snow cover has also been part of many, many other studies. So we see here a very nice figure for the French Alps. And this shows the number of snowless days. So the green areas are basically the days where we do not have snow. The white areas are the days with snow. And on the y-axis here, we see the altitude. On the x-axis, we see the different months. And in the past, we had basically no snow from end of April until end of November. And now this has been changed. So now we have already starting from April until early December, we do not have snow. And the interesting fact, what we see here is that in the lower altitudes, 1,500 meters and below, this decrease in the snow days was about 10%. And especially in the higher altitudes, so 2,500 meters, we see that this decrease is almost 25%, which is quite alarming. There's another quite nice figure that was developed by the German Aerospace Center. So they took remote sensing pictures, satellite pictures from the Aosta Valley, which is a very nice valley in Italy, actually. And they checked the snow line in different periods. And what you see here in yellow is the long-term average of the snow line in March. And in blue, you see the snow line in March 2022. And in some places, the snow line has increased by more than 600 meters. And this was quite dramatic. And this also had some long-term impacts. So maybe you've heard of it. So Italy suffered from a severe drought in 2022. And one of the reasons for this drought was the snow-poor winter. And here you see some pictures from the Po, from the river Po in Italy, which is one of the main rivers in Italy. And the Po also gets water from this Aosta Valley. So this basically shows that this decreasing snow has also some long-term impacts on water, on droughts, and so on and so forth. So if we have less snow and warmer temperatures, this leads obviously to more vegetation. So the Alps are getting greener. So this is a study that has been released in 2022 in Science. And they were checking the NDVI as an indicator for the vegetation productivity for a quite long period of time. And they could find out that the vegetation above the tree line has increased by 70% since 1984, which is quite a lot. And first of all, we would maybe think, okay, that's quite a nice effect. So greener Alps does not sound too bad. But it means that the native vegetation gets basically thrown out and new vegetations, new plants colonize now in the Alps. And even maybe more alarming, the greener mountains also mean less albedo, which means less sunlight is reflected in the atmosphere, which means, again, we have a kind of feedback effect. So the Alps are warming even more. So we have higher temperatures, we have less snow, and this obviously has a lot of impact on the permafrost. So the permafrost is usually the region above 2,500 meters. And here's a very interesting study from 2019. And they have actually checked the damage on infrastructural elements above or on the permafrost. So things like cable cars, hats, and so on and so forth. And they could actually associate these damages with the melting permafrost. And this is now basically a snapshot from the French Alps, but it's quite easy to extrapolate this also to other regions. And this means that the costs that come here, they might be quite dramatic. So that's about the state of the art. Somehow this trend will, of course, continue. So there are now first, not now, but there is now quite a rich database of climate predictions also for the Alpine regions. Now we are also in a state where we can do quite high resolution simulations, which is necessary if we really want to know what is going on. And one of these simulations is shown here. Basically, it's from a study that was released in 2022. And in this study, so I really have to practice this term, it's very complicated. They were investigating the environmental equilibrium line altitude. And this is basically the line, the altitude on a glacier where the snow accumulation is equal to the amount of ice and snow that melts in summer. And they were checking if there have been changes in this altitude, and they could find out that this ELA has risen by 114 meters in the last 120 years. And they could even show that in some regions, this ELA is about above the highest mountains. So there is no equilibrium anymore, which means that mass is decreasing. For this, they were also checking a lot of different climate predictions, and they could see that basically for all RCPs, temperatures are, of course, rising. And if we take our worst case scenario, RCP 8.5, they could see increases of up to 6 to 7 degrees until the end of the century, which is quite alarming. So much about it for the, let's say, the whole Alpine region. So in the next couple of minutes, I would like to zoom in a little bit on the region here, and also present to you that also here some things are happening. Maybe first of all, a couple of words to the region in that we are located here. So the region here is called the Bavarian Oberland. It's located between Munich and Innsbruck, consists of 4 counties. It has an area of almost 4,000 square meters, and almost 500,000 people are living in this area. And as you can imagine, and as you might have also noticed if you look out of the window, this region is strongly characterized by agriculture and tourism. So basically 2 sectors that are highly vulnerable to climate change. And due to this vulnerability to climate change, there was and is a very nice project, an interesting project that is called KARE. And that is basically investigating the impact of climate change on this region here. And within this project, they did a very nice survey. So they were asking the municipalities around, and they then somehow concluded that 90% of the municipalities have noticed climatic changes in the last 10 years. 90% have faced extreme weather events. More than 75% have been affected by heavy precipitation and flooding. 65% have experienced storms and strong winds. 50% have dealt with high snow loads. 1/3 have encountered periods of severe heat and river floods, and even 1/5 were struck by drought. So basically, we have climate change bingo also here in this region. Here are some pictures from some of these events. So that was in 2018, the Patnach flooding right here out of the door. And there was even 1 person killed in this event. I mean, it's not comparable to the R flooding, but for this region, it's still quite dramatic. Then 1 year later in Oberammergau, which is also nearby, we had a quite severe flooding. Then in the city of Bad Bayersoien, this was in 2022, and only 1 year later, they were struck by a massive hailstorm that basically destroyed all the roofs in this city or in this village. And just during this year, this was a picture from the Zugspitze in summer this year. In the valley, they were dealing with flood situations, and that was on top of Mount Zugspitze. And to put it a little bit more drastic, so on the right-hand side here, we see a drought map for Bavaria. So we are located in the southern region of Bavaria here. And in March 2022, for example, we had drought conditions here in Garmisch, and only a couple of months later, we had a big flooding. And the same effect was seen also in 2023. So in July, we basically had some very severe drought conditions, and only 1 month later, we had this enormous hail event, also with flooding and so on. So again, also here in this region, you see this huge contrast of these climate change effects, with these extreme events. And if we look now in the past here in the region, we also can very nice visualize the trend, at least in temperature here. So this is now the mean annual temperature. It's derived from a data set from the German Weather Service. And this time series starts in 1951. And one of these columns are always 10 years. And it goes all the way up until 2020. And then what is shown here is the temperature anomalies with respect to the long-term mean from 1951 to 1980. And very similar to many other publications, data sets, and so on, we see also here a quite warming trend. So we start here in these bluish maps, and we see that especially in the last 10 years, the image has become quite red. We see only very little regional patterns, so there are no real gradients. We see basically this warming all over the overland. And maybe this should not be a surprise for you as experts, but we still, despite climate change, we always still see these cold years. So even in the future, also cold years might still show up. Maybe a little bit more visually appealing, if you want to call it like this, is here a picture from this Bavarian glacier report. So warming temperatures means our glaciers are melting, and this is also happening to the glaciers that are or were here in the neighborhood, basically. So this is the northern Schneeferner. So all these glaciers now are located in the region of the Zugspitze. And in blue, you see the area that was covered by the glacier in 2006. And here in yellow, you see the area in 2018. So this is a picture from the southern Schneeferner. Also, the same effect can be seen here. So, and again, for the Höllentalferner, which are the three glaciers that are located right here in front of the Zugspitze. And this even led to the southern Schneeferner, they lost the status as a glacier. So the southern Schneeferner is now not called a glacier anymore. And on the Zugspitze, there was also another record this year, actually. So it was the first year where there was no snow, no frost day in August. So this is also the first time since they ever recorded temperatures on Zugspitze. So also here we see this dramatic effect of global warming. Switch this. So if we look at temperature, precipitation, the picture is a little bit different. So here you see now the mean annual precipitation in the Oberland. Again, the data is coming from the German Weather Service, and you see in the background, you see a gridded data product, and these blue dots, these are stations operated by the German Weather Service. And we can see this gradient very nicely. So we have less precipitation in the north, where it's getting flatter, and when it gets to the mountains, it's getting wetter and wetter. And here we see now the period from 1951 to 1918, so the long-term average, or the climatology. And if we switch to a more recent period, 1991 to 2020, we actually do not see a big difference, right? So we still see this gradient, but the colors do not change dramatically. And if we look at the relative difference, we also do not see a huge change that we would somehow associate with climate change. So we are always more or less in the region of -5 to 5% of total annual precipitation. The situation looks a little bit different if we look at the seasonal precipitation. So here we see the changes in the seasonal precipitation. So in winter, spring, summer, and autumn. And here we see a quite significant change. So in winter, we see these bluish areas. In summer, we see these reddish areas. And also in summer and autumn, we also see these bluish areas. And this shows us that we will get more precipitation in winter and autumn and less precipitation in summer. And this is also something that we expect from climate change, that the periods of drought are getting longer and longer. And when it starts to rain, it starts to rain really heavily. And this is also something that we see here in the data. But of course, in terms of precipitation, especially in complex terrain, like we have it here outside of the window, we see very strong local differences. Then this is one study that was done by a colleague from the University of Augsburg. So they did a first look into the future of this region here. So here in this gray area, you see Bavaria actually. So we are located down here somewhere. And this is a climate simulation, a high resolution climate simulation until 2050. And it was actually the first convective climate simulation for this Alpine region, which is quite important if we want to get precipitation right, to do this in a convective permitting way. And now we can just start this small animation. And again, what is shown here are the temperature anomalies with respect to the 1991 to 2000 average. And we see a very similar picture, like we have seen it quite often. It's getting redder and redder and redder, but we still see these bluish maps, which means that some relatively cold months are still possible to occur. But overall, we also see here in the region this warming trend also to continue in the future. So we see locally an increase of up to 4 degrees. And again, what has already been discussed before, the most significant anomalies occur in high altitudes. And as already mentioned, even in the changing climate, there will be cold summers and winters. So in the last couple of minutes, I would like to show you a little bit of things that we do here in terms of alpine research, or maybe not research, but at least monitoring. And maybe one of the most important things that we do here is the maintenance or the operation of the Tirreno Pre-Alpine Observatory, because you have seen a lot of pictures where data from stations and models have been mixed. So we still need station data, and this is what we do here in the Tirreno Pre-Alpine Observatory. It's located in the south of Germany. It spans an elevation from 600 to 1,600 meters. The main land use is forest and grasslands, and we have, as you already have seen on the maps before, we have strong climatic gradients and complex topography. And what we do here in this observatory is basically to work on impacts of land cover management and climate change on ecosystem atmosphere cycling of the energy. And what we do here is the long-term monitoring of climate variables. We do a lot of interdisciplinary measurement campaigns, and we, of course, use all these measurements to do the evaluation of models and of also remote sensing products. And maybe an interesting result from this KARE project. So this is another thing that we do here right on in front of our door. So what you see here, maybe some of you have recognized this. This is our institute. And this is now a model that basically describes the flow of water after a precipitation event on a very, very high spatial resolution. And what is quite cool is you can really see how the water flows around this institute, how it flows on the water on the street. Scary, yeah. And of course, the idea would be to provide such information to local stakeholders, so the fire people or some other people that might use such information when we really have a flooding event, that they know where to go actually. And last but not least, we had a very nice project that was called Studio. And in this project, we got the opportunity to develop a kind of drought forecast for this region here. The project has unfortunately ended already last year, but I still do want to show at least one picture from this project. So that was a categorical temperature forecast for July in the Oberland. And here we were using seasonal forecasts with which we tried to forecast the coming 6 to 7 months. And you see here now this categorical forecast. And the forecast for summer 23 was that it will be abnormally warm. And this was actually, for last year, it was actually true. So the forecast was quite good. And such data, of course, could be used as decision support for water management, energy providers, agriculture, skiing resorts, and also tourism. So although it's not too much what we do here in the region, we still do something. And I think that's quite important. So that's it, basically. And I thank you for your attention.
Thanks very much. It was really interesting. It's also forecast this year's cold and wet and general miserable summer. Please do that for me next year again, so I can plan my summer holidays. And
I promise.